I'm willing to bet that anyone who has experience with cloud deployments could give you some horror stories about deployments that went wrong. Sure, when things are going great, it's all good. But then one day some red error messages appear, and I'm left with a classic debate. Hunt down someone I work with who's better at these things, or thumb through Terraform files, pretending I know what I'm looking at and changing stuff until something works. Here to hopefully give me better insight for future cloud deployments is someone we're very lucky to have at ETE, author of 2 books published by O'Reilly Media, Hello Startup and Terraform, up and running, Yevgeniy Brikman. Over to you, Yevgeniy.
Thanks very much, Jack. Hi, everybody. Thank you for joining. Let me share my screen. Bring up the slide deck. All right. Hopefully you can all see the slides at this point. If not, Jack, give me a shout. So this talk is called Cloud Adoption Fails. And what I'm going to talk about is 5 of the ways that I've seen companies try to adopt the cloud and things have gone very, very wrong. And these are just 5 of many, many ways that things can go wrong. And then I'll share 5 solutions. And what's interesting is these solutions tend to be pretty much the same across all companies that successfully use the cloud. Another way to put it is all happy cloud deployments are, excuse me for just a sec, I think some Zoom issues. There we go. All happy cloud deployments are alike. Each unhappy cloud deployment is unhappy in its own way, which is a wonderful piece of wisdom we got from Leo Tolstoy, a well-known site reliability engineer. Let me provide a little context for this talk. So I am Yevgeniy Brikman. I go by the nickname Jim. And I'm the author of a couple books, Terraform Up and Running, Hello Startup, that talk quite a bit about cloud and DevOps, and also the co-founder of a company called Gruntwork, where we do a lot of DevOps. And this is really where a lot of the context for this talk comes from. At Gruntwork, I've had the privilege to work with hundreds of companies as they've adopted the cloud. And I've seen some of those processes go well. I've seen some of them go not so well. I've seen some things you really wouldn't believe. I was considering reading this quote, but I realized after putting this together, I can't possibly do justice to this wonderful scene from Blade Runner. So you can just enjoy reading this lovely slide shared as a meme on social media. The gist of it is this. A lot of companies try to adopt the cloud and a lot of them struggle. Sometimes they fail completely and abandon the efforts, but even more often, it's just really expensive. It takes forever. It doesn't give them the benefits that they wanted. Why? Why is it so hard to use the cloud? And I think there's a lot of reasons. In this talk, I'm going to focus on one particular idea. And that's the fact that when most companies are adopting the cloud, when they're moving from their own data center to AWS, Google Cloud, Azure, they're not just adopting the cloud. They're actually changing everything about how they build software. And this isn't necessarily obvious when you start out, but once you get into it, you realize just how many things are changing. So this is a very short version of just a few of the things that are changing when a company goes to adopt the cloud. One of the bigger changes is if you are used to having your own data center that you're managing, you probably had one team, your devs, who were responsible for writing your application code. And when it was done, they toss it over the wall to another team called ops, who were in that data center. They were physically racking servers, connecting cables, et cetera. And they would also be responsible for deploying that code. And one of the big changes with moving to the cloud is now both of these teams spend most of their time writing code. And they're actually both heavily involved in deploying that code. So these teams need to work more closely together. You have to change how they work. This is where this whole DevOps movement comes from. Moving to the cloud also changes, of course, how that data center works, right? You went from your dedicated physical servers to elastic virtual servers, connectivity changes, security changes, how you provision things changes. There's just changes across the board. Now, for the most part, these are good things, right? The big, wonderful advantage of the cloud is once you've made these transformations, if you do them correctly, you'll go from deploying once every few months, or some companies deploy just once or twice a year, to deploying many, many times per day. And the amount of time it takes to go from an idea to something running in production drops dramatically if you do it right. But to get there, you do have to go through a huge amount of change. And companies that aren't aware of this, that try to adopt the cloud without acknowledging all of the changes they're going to have to make, run into a lot of problems. So that's the focus of the talk. I'm going to present 5 of the biggest problems, 5 of the biggest failures that these companies run into. And these are not all the types of failures. There are many kinds, but I'll focus on the 5 most common ones. And I'll also present 5 solutions. And these are things that we've seen work at many, many different companies. And these solutions tend to be the same across all of these companies. The 5 solutions are part of something that we've called the Gruntwork production framework. And a lot of what I'm going to be doing in this talk is building up your mental model of why these solutions are useful, valuable, why you need them to use the cloud effectively. If you're interested in going to like full detail on this framework, it is on our site. I'll also share this slide deck in the Room C Slack channel. And if you have any questions during the talk, please put them in that channel. And at the end of the talk, I'll try to answer as many of them as I can live. And then I'll also answer them asynchronously after time has run out. So Gruntwork production framework is what we're talking about. And the 5 problems that we're dealing with are the ones listed here. And I'm going to go through each one, explain what it actually is, and then talk about how to solve it. So we're going to start with this very first problem, do it by hand. So what am I talking about here? So the number one cause of failure, the number one cause of problems that we've seen when companies go to use the cloud is the following. They try to do it by deploying and manage everything using the web console. Here, this is a screenshot of the AWS web console, but it's the same issue if it's the Azure console, the Google Cloud console, whatever other web thingy you're using. Often the nickname for this thing is ClickOps. And just about everybody starts this way, right? That's kind of how you learn, and that's completely fine. It's even okay as a debugging tool because having a web UI to visualize things is very useful. But it is not a great way to manage your production infrastructure. Beyond just the smallest scale, it just doesn't work. And almost every company that goes with ClickOps that manages things by hand ends up regretting it. ClickOps has a whole bunch of problems. It's slow, takes hours and hours to deploy things. You get no reuse. So even though you spent 5 hours deploying that environment, if you want to add another environment, that's another 5 hours. You get no leverage. There's no audit trail. All the information about what happened is trapped in one person's head, usually. And there's no versioning, so you have no idea how it's changing over time. It's very error prone. Anytime you have a human in the process, there's a chance they're going to make mistakes. So now you have deployment problems, you have outages, you have Snowflake servers and environments that are each configured just a little bit differently, which makes debugging impossible. Because it's all manual, you can't use any kind of automated testing. And it's tedious. Developers, ops people, nobody enjoys sitting around clicking for hours and hours, especially in a high stress situation where if they make a mistake, there could be some sort of outage or data loss. And so the inevitable result for companies that go with ClickOps looks something like this. We've had many, many companies come to us and tell us a story along the lines of, we just spent the last year migrating to the cloud. We had almost everything set up, and then that one engineer left. And now we have no idea how to manage our own infrastructure. And so you get this like 10,000 foot stare from Napoleon over here, from this classical painting from 1887, where they've put in all this work, they've put in all this effort, and now they have absolutely no idea how things work. Everyone's afraid to touch it. They don't want to cause outages. It's not a good place to be. Quick side note, I'm going to use a few of these classical paintings in this talk. I've borrowed them very heavily from this classical programmer paintings blog. Definitely worth checking out. They have a lot of good humor on there. Okay, so how do you solve this problem? What do you do about ClickOps? How do you avoid that 10,000 foot Napoleon stare? The solution that I recommend is building something called a service catalog. Now, this term is very overloaded and has a lot of meanings, and some of you might be cringing hearing it. So let me define what I mean by that. So I'm talking about a modern service catalog. A modern service catalog has a few really important properties. The first is that everything in that catalog is defined and managed as code. So as opposed to managed using ClickOps or a web UI or some sort of, it's not even a platform as a service. If you're a small little startup and you can use a platform as a service like a Heroku, you should, and that's fine. But beyond that, once you're in the cloud, once you're at any kind of scale, you need to manage things as code. It's the only way we've seen that effectively works for managing the kind of complexity you're dealing with, managing the customizations and control that you need. It's the only way I've seen to scale across a large organization. And it's the only thing I've seen that can actually handle as the amount of change that you go through We'll talk about change a little more later, but let's just put it this way. None of the stuff that we're using today in the cloud is sitting still. It is all evolving. And so code is the only way we've seen that helps a company effectively deal with all of those issues. Which tools you use is up to you. Pick the ones that fit your company's needs. You can use things like Terraform, CloudFormation, Pulumi, Docker, Kubernetes, whatever fits your needs, as long as you're managing things as code. This is, I would say, a central point throughout the entire talk. I'm going to repeat this again and again and again. So apologies, but hopefully if one thing sticks in your head, it's this idea that if you want to use the cloud and you want to be successful with it at any kind of scale, you need to manage things as code. Second key idea with a modern service catalog is that it is designed explicitly for use in production. A lot of the stuff that you find out there is really built for a 5-minute demo, right? You like click around a couple times and ta-da, I have this amazing Kubernetes cluster, which is great. It looks cool, but you can't actually use it in production, right? It's like not scalable, it's not highly available, it's not secure, et cetera. The kind of service catalog I'm talking about is explicitly built for production use cases. And it's designed specifically to meet your company's requirements. Each company is a little different, but you probably have some set of requirements around scalability, high availability, security. You probably have a bunch of compliance requirements. These things need to be captured as code. And that's a really critical idea, is you're not just meeting compliance by saying you're doing it, you actually encode those compliance requirements in your service catalog. Another key property is that it's tested. So one of the lovely things about code, one of the reasons it scales and works so well, is that you can test it. And you can test it across many different levels. You can do code reviews, you can do static analysis, you can do functional testing, policy enforcement. That's a new area that's really evolving and ties closely to compliance. So one of the things we've heard from a lot of auditors is in the past, they would say, hey, how are you meeting requirements ABC of, let's say, SOC 2 compliance? And the answer used to be, well, we have a wiki page and we have a PDF that every employee reads and signs. And that used to be good enough, but these days, policy enforcement is happening through code, using tools like OPA, Open Policy Agent, using tools like TerraTest, using tools like SteamPipe. You can actually check that you're conforming to various policies automatically and on a continuous basis, which is much more powerful. And auditors are looking for those kinds of things. The final thing that I want to mention about the service catalog is that it includes both code for infrastructure and applications. So what do I mean by that? So for infrastructure, let me pop open this link really quickly. So this is going to look at one small part of that production framework. I'm not going to read all of this. I just wanted to give you a high level view. So the kind of infrastructure code you want in your service catalog includes things like the basic account baselines. So how do you do authentication, authorization, guardrails? We'll look at this a little more in a minute. How do you do networking, VPCs and VPNs, monitoring, alerting, log aggregation, a bunch of security concerns like secrets management and encryption. Of course, you need all your application orchestration, right? Do we use virtual servers or do we run in Kubernetes or some serverless solution? All your data stores in your CI/CD pipeline. So this is a very minimal set, but you need code for all of these things in your service catalog. And the interesting thing about this is what this ends up being, what this service catalog becomes, is it is your company's personal private API for how you use the cloud. So instead of having your developers run around and willy-nilly use the cloud APIs directly, you are exposing a higher level API in the service catalog, and you're ensuring that as long as developers are using that API, all of your basic company requirements are going to be met. But on top of infrastructure code, you also have application templates. So by applications, I mean the web services that your developers are building, a Spring Boot app with Java or a Node Express app or a Ruby on Rails app, things like that. And the thing about those apps is in order for them to run effectively in the cloud, there are a whole bunch of problems you need to solve. Again, I'm not going to read all of this, but it's things like how do we package apps? Is it a Docker image or a virtual machine image or a jar file? How do we do testing? Where do we read secrets from? How do we do service discovery, logging? If you have 10 teams, you don't want 10 different answers to these questions, right? You ideally want one or some very standardized set within the company. And the way to do that is to put application templates in your service catalog that define the answers to all of these questions as code. Now, if you do that, this becomes your API between the cloud and the apps. This is basically you saying, in order to put an application in production in our cloud, here's the API effectively that you have to implement. So that's a really powerful thing to define. If you don't do this, by the way, what ends up happening is at most companies, if you go to 20 people and say, what do I have to do to go to prod? You get 21 answers. If you define this as code, you get one answer and it actually works. Taking this one step further, just to make it concrete, I want to show you an example of a real service catalog so that you can see what I mean by it's defined as code, what a modern service catalog looks like. Because I don't want this to sound like some hand-wavy magical thing. It's actually a very, very straightforward, concrete thing. So I'm going to pop open the Gruntwork service catalog. You can see over here, here's all the infrastructure templates that I talked about, app orchestration, data storage, landing zone. And I can open up one of them and go to like Kubernetes, and you can read through the stuff, but the piece I wanted to go to is to actually go look at the source code. So this takes me to a GitHub repo. And when I say these things are defined as code, I mean that in the most literal, straightforward sense you can imagine. So here we have a module for how we at Gruntwork run a Kubernetes cluster in production on EKS. And we define that all of that stuff is captured as code. We happen to use Terraform. You're welcome to use any other tool that fits your use cases. And in here, we have captured as code answers to really important questions like, how do we authenticate to the cluster? How do we configure our control plane? How do we configure worker nodes? How do we do IAM roles? And so on and so forth. And the point is, all of that is captured as code. And so anybody can show up at the company a year later, 5 years from now, read it, understand what's going on, look at the version control history, see how it's evolved. All the requirements are defined as code. It's really powerful. And again, it's not just for infrastructure code, it's for applications too. So if I pop open this repo, this is our, it's a Node.js application, but that's just what we happen to use internally. The important part is it shows the patterns that we use to run our apps in the cloud. So those patterns are, how do we package this thing as a Docker image? How do we fetch secrets and handle them securely so we're not accidentally dumping them to disk? How do we do schema migrations, run tests, et cetera? And again, none of this is magic, it's code, right? So you can like browse through this repo and you can see how we do, for example, service calls. And if you read through this code, it gives you an example of how to talk to another service using service discovery that works with Kubernetes, that works with local environments, et cetera. So that's the basic idea behind a service catalog. Hopefully that gives you a concrete example of what I mean. And that's key idea number one from this talk is you want to manage everything as code in a service catalog. I'll share a bunch of key ideas as we go through the talk, and then I'll recap them at the end. So you want to manage everything as code, and I do mean just about everything. These days, you can manage more and more things as code, and that's a very good thing. So we've gone, for example, from manually provisioning infrastructure, literally racking servers, to infrastructure as code. We've gone from manual build processes to continuous integration. We've gone from manually enforcing policies to automated tools like OPA doing it for us. And that solves a lot of the problems that we had with ClickOps, right? These were the problems that we ran into with ClickOps. If you move to code, if you do it well, then a lot of those problems go away. Instead of slow deployments, things happen very quickly because computers, that's what they're good at, running things fast. You get huge reuse and leverage. If you took the time to figure out how to run a Kubernetes cluster once, now you can use that code over and over again in all of your other environments. You can also leverage the work of others, other teams, the open source community, et cetera, and you can evolve that code over time. Also, all of the code is stored in version control, so you can see how it evolved. You can see the history, which is wonderful for debugging and understanding. It's also much more reliable. It's reliable inherently because it's code, so it's not making human errors, but it's also more reliable because you can do code reviews, you can do automated tests as well, and it's more enjoyable. People don't like doing the same thing, the same tedious process over and over again. That's better left to computers, but people do enjoy being creative, writing code, et cetera. Okay, so that's item number one, move from ClickOps to managing things as code in a service catalog. That's kind of the basis for the whole talk. Item number two, do it live. So fail number two is the following. It's making everyone at the company an admin. In other words, giving tons and tons of developers in your company really powerful permissions in your cloud environments. Now, most companies don't start this way, right? Most companies try to do the right thing, try to go for principle of least privilege, but it's hard. It's hard because in most cloud environments, you use IAM, identity and access management, to manage permissions And in all of the clouds, IAM is complicated. It is hard. This is a diagram, a simplified diagram of how AWS IAM makes a decision on whether something is allowed or not. And this excludes a lot of really important, messy details. And it's a really painful process to work with this. Because when you are trying to do something, really all you get is an error like access denied. You don't know where in this giant diagram things were denied, just somewhere along the way, IAM said, nope. And so you keep trying things, you keep getting rejected. You keep trying things, you keep getting rejected. It gets really, really frustrating really quickly. And inevitably, most people give up and they say, screw it, we'll do it live. I'm going to try to avoid cursing too much in the talk. They say, screw it, we'll do it live. And they make everybody at the company an admin. And that solves the problem in a sense, because once you're an admin, basically everything is allowed. But it creates a whole bunch of new problems. And it's actually a very, very problematic way to solve it. So what are the problems with everybody being an admin or everybody having these really powerful permissions? Well, first of all, your security model is just a mess. Any mistake you make can have huge repercussions. If those credentials are leaked, it is a severe security incident, and it's really hard to protect against it because any guardrails you put in place, well, admins have the powers to remove them. It leads to sprawl. You end up with tons of accounts and tons of resources and no way to manage it. You have no consistency. Everything's configured just a little differently, and it's really hard to fix this later because of how complicated IAM is, right? You're like, well, no problem. I'll just take away the admin permissions later. Okay, but if we go back to this diagram, there's like 25 ways to grant yourself access to something, and it's possible the admin did that. And so even though you remove their admin permissions, they still have access through one of these other mechanisms. So it's really hard to clean this up and feel confident like you got it right later. So we end up with lots and lots of companies that come to us and they tell us more or less the same story. Hi, we have 143 AWS accounts. They have thousands of resources in them. We're spending millions on AWS, and we have no idea how to get this stuff under control. Can you help us? So what do you do? Solution number 2. What I would recommend here is to set up your landing zone as early as you can. So landing zone, it's a little bit of a buzzword that showed up over the last few years, so I'll try to define it and some of the related terminology. A landing zone is a streamlined, it's the official way to create accounts so that they're configured out of the box with all the best practices you need, including, of course, authentication, authorization, so not everyone is an admin. One little note is each cloud calls these things a little bit differently. So in AWS, they're called accounts. In Google Cloud, they're called projects. In Azure, I think they're called subscriptions. I'm just going to use the word account, but it's the same concept everywhere. So to have a landing zone, there are 3 key ingredients you need to figure out. The first one is your basic overall account structure. What I mean by that is when you use the cloud beyond a tiny little scale, you almost always end up with multiple accounts. Typically, that's a way to isolate or compartmentalize different parts of your organization, different teams, different products, different environments. So you end up with lots and lots of accounts. And you need to understand how to structure those so that they can all work together and operate correctly. And the way this works is different in every cloud. So this is an example of like an AWS account structure, and there's certain accounts on the left that are shared, and there's certain accounts that are team specific, and so on and so forth. This affects how you do auth. So you need to figure this out for your particular cloud in your company as early as you can. Once you understand what sort of account structure you're aiming for, you then need to set up account baselines. So an account baseline, this is the basic set of controls and practices that you install in every single account, including things like the authentication and authorization solution. So here's a slightly more complete list. I'm not going to go through every item in here, but account baselines define the baselines, right? So it's things like auth-n, auth-z, monitoring, networking, hardening, etc. So there's a whole bunch you need to do in those baselines. And the key idea is you want to define those baselines as code. So this is the same thing that I talked about in the first part of the talk, right? You need to manage things as code. So a landing zone, really, it's part of your service catalog, and it is defined and managed as code. And so this is an example of like some Terraform code that sets up an account baseline. In here, you can see there's child accounts defined. So there's a dev account, stage, and prod, and it'll apply a baseline to each of those accounts. The reason you need to manage it as code, same as earlier in the talk, and it's quite visible with account baselines. There's just a tremendous amount that you need to do in those baselines in order for things to work well. And trying to do that manually doesn't work well. Trying to manage it in like a wiki page doesn't work well. You really need to manage it as code. And it's also worth mentioning, all of these things are changing. So again, code helps you keep up with that. The final ingredient with landing zone is you typically want what's been called an account vending machine. This is basically your formal official tool or just a process for how you spin up a new account and can be confident that it's configured with the proper baseline. The key pieces that you need in an account vending machine are, it should be self-service. In other words, teams all around your company should be able to use it to get a new account without having to ask somebody else. I'll talk about self-service a lot more later in the talk, so just keep that in the back of your head for now. Second is it's GitOps driven. In other words, somebody does a commit to version control. That's what triggers creating the new account. That also triggers applying a baseline automatically to the new account and granting the team access that requested that account. And people hear vending machine and they go crazy and they try to build all these fancy things. It doesn't have to be super, super complicated. A very simple account vending machine is to just use code, right? Yet another reason to build everything's code. So here, for example, the process you could define for how you spin up a new account in your company is you tell developers to open up a certain repo, open a certain file, and add a line or two of code to it. So here I'm adding a line to add a new account. You then open a pull request with that change. It gets reviewed, automated tests run against it, which we'll talk about more later. And then when it's merged, the CI/CD system rolls this thing out, applies the baseline, and grants access to the developer who added this. So this is a perfectly reasonable account vending machine. It's some code in a repo. That's a good starting point. You can build fancier stuff later, but at least get this working for your company as quickly as you can. So key idea number 2, get that landing zone set up as early as you can. It's much harder to fix this later. So the earlier you do this, the better off you are. This is usually the first thing you add to your service catalog. Okay, item number 3, do it on my machine. So the third thing that we run into with many, many companies is this, that all the deployments are done by a human being on their own computer. This could be some dev person or some ops team member, but the key idea is they're doing it on their own computer and they're doing it themselves. So even if you define everything as code, even if you have a lovely service catalog, if you're doing the actual deployments on someone's computer, you're still going to run into a bunch of problems. What are those problems? Well, first of all, it's error prone. If you're asking a human being to follow a set of steps, they're going to make mistakes. They're going to run the wrong command. They're going to forget some critical step. You're going to have outages. You're going to have problems. It's not reproducible, right? Each developer's computer may be just a little different dependencies. They might have code they forgot to commit, and then they deploy something, and you have no idea where that change came from. You also end up with a low bus factor. So if you're not familiar with the term, bus factor is this kind of silly idea of you ask the question, how many people on your team could get hit by a bus before your team can't operate at all? And if you have a bus factor of 1, where like there's one person that if you lose them, that's it, your team grinds to a halt, that's a really bad place to be as a company. So if you're deploying things manually, what tends to happen is 1 or 2 people in the company are the only ones who actually know how to do it right? Like they're the only ones that know the magical commands and all the authentication details. And so you have a really low bus factor, and eventually those people go on vacation or they leave the company and things really grind to a halt. You also run into race conditions because there's no way to ensure that developers are running on the same branches. Maybe somebody forgot to git pull the latest code before running a deployment. So you end up with conflicts where somebody deploys something and then somebody else accidentally undeploys it. And it's not secure because to deploy those things, you typically need admin permissions. We already know the problems with that. So we have had many companies and many developers who come to us and look something like that, because if you are relying on developers deploying things from their own computers, it's not an if, it is a when are they going to accidentally run some disastrous thing in production. They run Terraform destroy, they run drop tables, they run RMRF, whatever it is, they end up looking like this, pretty much guaranteed. So how do you solve this one? The answer is you have to set up a CI/CD pipeline to do your deployments. I think a lot of people are aware of this, but there's some really interesting challenges here that I think catch people off guard. So CI/CD pipelines. I'm not going to go through all the features. I'm just going to focus on a couple of the key ones just to try to keep us on track with time. First of all, as everything else, your pipeline should be defined as code. It shouldn't be some UI-driven thing. It shouldn't be somebody manually doing anything ever. It should be defined as code for all the reasons we talked about earlier in the talk. It should run automated tests. That's a really important job of this pipeline, and we'll come back to test a little later. And then I'm going to skip down here, this is kind of the unintuitive part, is you need the pipeline to work for both your application code and your infrastructure code. And today, I think a lot of companies are starting to really get the idea of good CI/CD pipelines for application code. And I think the practices and patterns for doing that are relatively well understood. But for infrastructure code, I think most companies are still struggling and getting it wrong. So that's the one that I think is really problematic, especially with cloud deployments, because it's completely new, right? All of your infrastructure is now software. Now you have to have a pipeline for your infrastructure, and people just don't know how to do that. So I'll give you a very quick high-level overview here of what are some of the differences between pipelines and workflows for application code and infrastructure code. So on the left side here, we have application code, and on the right side, we have infrastructure code. So you can see the high-level workflow is very similar, but there are some important differences. So it actually starts before you even enter the pipeline itself. It starts with some developer making a change, right? You got to check out the code, make some code change, test it locally, and then you're going to open a pull request and put it through a pipeline. So the big difference here is that with application code, you can run the app locally on localhost on your own laptop. With infrastructure code, you can't. I can't meaningfully deploy like an AWS VPC on my own laptop. That just doesn't make sense. So I have to have access to the cloud to test and make changes to infrastructure code. And so what that implies is you're going to need to set up sandboxes where your dev, your ops teams can do that. And I'll come back to sandboxes a little bit later in the talk. Then you made your code changes, you submit a pull request, that looks the same. Then you're going to run tests. I'm not going to get into too much detail here other than to say that it's a lot harder to do automated testing for infrastructure code, but it is possible. And later in the talk, I'll give you a link that goes into more detail on that. You then release the changes, which looks pretty similar. And now we come to the biggest differences, which is how does the actual deployment happen from a CI server? And there's two really major differences. The first one, it has to do with permissions. In order to deploy app code, typically the CI server needs very, very limited permissions, basically enough to trigger some orchestration tool like Kubernetes and say, hey, please deploy this Docker image. With infrastructure changes, if you're going to be deploying arbitrary infrastructure changes, you need admin permissions. And I'll talk about that in just a couple of minutes, but basically giving your CI server admin permissions is not a good idea. So there's a different pattern that you should use for that. The second big difference is in terms of the deployment strategies you have access to. With application code, you can do rolling deployments, blue-green deployments, canaries, you can use feature toggles, et cetera. With infrastructure, you basically have none of that. You can maybe run plan and have like a human being do an approval workflow and say, yeah, I think that looks okay. But at some point, you just kick off the deployment and you hope for the best. And so that has some implications about the due diligence you put into testing and plans and approvals and things like that. But you can't like blue-green deploy a VPC change. That just doesn't really work. Okay, so those are some of the key differences. What are the key ideas? One key idea that is really important to be successful here in the cloud with this sort of thing is that the only thing that should be allowed to deploy to your production environment is the CI/CD pipeline. In other words, no developer, no ops person, no one has write access to production. Only the pipeline has write access. You might have like an admin as a backup, in case the pipeline breaks, but no one on a day-to-day basis has write access to your production environment other than the pipeline. The pipeline should be the only way to get code into production. That's really critical. Another key idea is the only thing the pipeline will deploy is code from your service catalog. You literally put an if statement into your pipeline where it will only deploy things that are coming from your own service catalog. Now, if you do that, so if you limit, if the pipeline is the only thing that can deploy and it only deploys from the service catalog, then what you've done is now the only way to get something in production is to use the service catalog and your CI/CD pipeline. And what that means is this is now the API between your ops team and your dev team. And that's a really powerful thing. This is basically the ops team saying, hey, devs, you can do this stuff as long as it's basically conforms to our service catalog and CI/CD pipeline. This is how you have that conversation. This is how you get those teams to work together, to come to an agreement of how these things should work. And if you do it right, it's very powerful and very effective. Okay, so one more key idea that I said I'd talk about is the CI/CD pipeline needs to protect its permissions. So the reason for this is if you're deploying arbitrary infrastructure changes, you have like a Terraform module or CloudFormation or Pulumi module that's deploying anything from a database to a VPC to an entirely new account, you basically need admin permissions. And I'm going to make the claim that granting your CI server direct access to those admin permissions is harmful. It's a really bad idea. Here's why. Your CI server becomes a combination of these three things. One, everyone at your company has access to the CI server. That's a good thing. You want developers using it, writing tests, running tests. Two, they use that CI server to execute arbitrary code. Again, that's the point of a CI server. But it's the third one. Once you give that thing admin permissions, now these three combine in a really dangerous way. And effectively, what you've done is you've made everyone at your company an admin once again, right? Because if I can execute arbitrary code with admin permissions, I'm an admin. And you can put some ACLs in place, but they're just not very effective. It's even worse than this. Not only is everyone at your company an admin if you do that, but so are a whole bunch of hackers outside of your company. So hackers are keenly aware of people granting CI servers these vast permissions, and they're starting to exploit it in the real world. And that's a very bad thing. You do not want hackers with admin permissions. Because after all, what's a CI server? It's basically a remote code execution vulnerability as a service. Like that's kind of the point of it. So it is a really, it's hard to protect it effectively. So what do? Well, you do try to lock down your CI server as much as you can, but there's one other really important thing, which is you do not give the CI server itself admin permissions. You instead keep those admin permissions on a separate, what I call worker. So if we look at this diagram, in the bottom left is the CI server, and this can be whatever you want, GitLab, CircleCI, GitHub Actions, Jenkins. It does not have admin permissions. Instead, the only thing that has admin permissions is some other service that you run in the world. In this example, we're using Fargate, basically serverless Docker container, but this could be Kubernetes, this could be Lambda, this could be a virtual server, whatever makes sense for you, as long as it meets the following properties. That isolated worker should be highly locked down. In other words, no one at the company has access to it, unlike your CI server. Two, the only thing you can really do with that locked down worker is trigger it via some sort of API. So your CI server, the only permissions it has is it can send a little API call to the worker and say, hey, can you please do something? And that worker, the API that it exposes is very, very limited and locked down. Basically, the only thing it allows is running predefined commands, maybe Terraform plan and apply, in predefined repos, in predefined branches, in predefined folders, et cetera, et cetera. So the idea is instead of having admin permissions with arbitrary code, so you can do whatever you want with those permissions, you have admin permissions that are really isolated and can only do very limited things with those permissions. And so that dramatically reduces the potential damage. So even if an attacker gets onto your CI server, which would be awful, but if that happens, they don't just get arbitrary access to admin. Okay, number 4, do it only on my machine. The idea here, the issue that a lot of companies run into is that the only folks who are allowed to do deployments are the ops team. So you might have a CI/CD pipeline, but everything has to go through ops. Ops has to approve everything, do everything, et cetera. Now, the reason a lot of companies end up in this world is for good reasons. Some of them started that way, right? Where you had the separate ops and dev teams that were like doing very different jobs. So that was kind of a natural setup. But even in the cloud world, it still often ends up that way because the ops team's job, in a sense, is to protect the company, right? To ensure that everything's okay from a security perspective, that data is backed up, that we're building scalable services, et cetera. And that often leads to a lot of ops teams acting as gatekeepers. And unfortunately, that backfires because in most companies, the ratio of developers to ops is at least 10 to 1. There's 10 devs writing app code for every poor one ops person. And so that ops person, that team gets overwhelmed and they become a massive bottleneck. Like everything grinds to a halt because of that. So what happens? Well, developers have a job to do. They're not just going to stop. So what do? They find workarounds, right? You have the ops team that says, this is the design. This is how thou shalt do things. And then the devs are like, yeah, that sounds great, but we're just gonna kind of do it this way instead. But of course, those workarounds create huge problems. They're usually not secure. They're usually not scalable. They lead to a whole bunch of fires. And so then ops is like, oh my God, I have to protect the company. So then they add more process. They lock things down. They try to block the workarounds. They add even more process. And eventually your company starts to grind to a halt as your ops team has its 95-step change request process, and the dev team looks on in absolute horror. And we've dealt with a lot of these things where companies in theory are using the cloud, but in practice, they're just using all of their old practices from the data center world, and those are not working well. They're not scaling. How do you solve this? The answer is you need to set for yourself as a goal to expose self-service to all of your teams. So the key idea here is any team in the company should be able to deploy their own apps and their own infrastructure with no gatekeeping, so long as that code is from your vetted service catalog. That's the key idea. And this is really important because the cloud, it's primarily a tool for developers, not ops, which is a little unintuitive, right? A lot of people think of the cloud as a replacement for the data center. That's kind of the ops domain. So how is this a dev tool? But really, one of the biggest benefits that the cloud brought is that it made developers self-sufficient. They didn't have to wait for some ops team to order servers, rack them, waiting months. They didn't have to ask for permissions. You could just go into the cloud and do things, and it happens in seconds or minutes. That's huge. That's where some of the biggest productivity gains come from using the cloud. The problem is if your ops team is a gatekeeper, you lose those benefits. The devs aren't self-sufficient. You're going to go very slowly. So the mindset, the proper mindset for using the cloud is to think of the ops team as enabling developers, as enabling self-service for developers, not a gatekeeper, but an enabler. And if you do that, you're going to go unbelievably fast as a company. Now, how do you do that? You kind of already know the answer to this for the most part. You enable self-service via the service catalog and the pipeline. So these two ingredients, I'm kind of repeating this a little bit, but they are your API on top of the cloud. So instead of saying, hey, developer, go and use AWS and Google Cloud directly, and who knows if our company requirements will be met, you're basically saying, we've built the service catalog and a CI/CD pipeline. Use these things. This is our safe to use API on top of the cloud. One of the things you're going to need for that to work effectively is all of your devs, and actually all of your ops people too, are going to need sandbox accounts. These are separate accounts. They're still part of the landing zone. They still have decent guardrails and authentication controls. But in these accounts, devs and ops do have write access. And you can use these things for testing, experimenting, learning, trying things out. And if you don't have this, basically, self-service is meaningless. Like you need a playground for developers to do these things and to try them out. But you don't leave it completely by itself either. You actually can set up cleanup tools within your sandbox accounts to ensure that those accounts don't cost you a fortune, that they don't leave things running forever, because developers are going to make mistakes. It's just human process is human error. So you set up tools to run in a cron job to clean those accounts up on a periodic basis. So for example, Cloud Nuke is a tool you can run and say, hey, delete everything in this account that's older than 2 weeks old. And that way, anything the developers are using today is untouched, but all the old stuff that they forgot about gets cleaned away automatically. In production, you do not give write access to dev or ops. Everything goes via the service catalog and your CI/CD pipeline. But it goes without gatekeeping. That's the key idea. So key self-service features, it should be GitOps driven, just like everything else in this talk. It's based off of code committed to version control. You can build a UI on top. It's very nice to have. It does make things much more accessible and easy to use, but I list it as optional because it's actually really hard to build. There's a new industry of like developer platforms coming out, trying to fill this gap, but no one has really cracked it. It's a really hard problem. And companies like expect this to cost 10 to 100x as much time as you think it will. So start with GitOps. That's usually the better start. And then later on, you can add a UI. And the other way to save time is to focus initially on just the most common important use cases. A lot of companies become paralyzed trying to provide self-service for everything, and then they basically provide it for nothing. If you just figure out what are like the most common use cases for my team, it's probably like create a new account, create a new data store, create a new orchestration, a Kubernetes cluster. If you can basically create self-service for those three, you can unblock your dev teams considerably, and then you can add all the other use cases later. And you can put some access controls in place in case, basically the most important use case here is for shared infrastructure, right? This team needs to share something with this team, so you need some way to control that. So self-service doesn't have to be fancy. This is the exact same example I showed earlier, where we're using code as our self-service mechanism. So the way that a developer can deploy something new, such as a new AWS account, is go into a repo, update some code, open a pull request. If the tests pass, that gets merged, deployed automatically. That's a perfectly reasonable self-service pipeline. One other key idea here is not only can any team deploy from the service catalog, but any team should be able to contribute back to your service catalog. This is critical. Modern software involves so many moving pieces. And if your ops team, if they're the only ones who can add those pieces to the service catalog, it won't work. They'll simply be a bottleneck. They'll have this endless laundry list of requests from devs. They won't be able to keep up with them. And basically everything goes slower as a result. A much better model is to allow anyone to contribute to the service catalog, but you can ensure that all of the company requirements are met by enforcing code reviews and by enforcing certain testing practices. And that way the ops team can do something much more scalable, which is review code rather than writing it all from scratch. And even more scalable, they can run automated processes to check for all the things they care about, like compliance and functionality and security. Okay, fifth item is do it once. So what's this failure? This one is based on the idea that you deploy things once and you don't have to worry about ongoing maintenance. As if things will just work by themselves forever after. Doesn't really work. Not only are there many moving pieces in modern software, but all of them are changing, right? So this is an example of AWS releases over time. This is how many announcements they have per year. We're talking thousands, and this only goes up to 2019. So many, many thousands. This is how many APIs they've added or changed. Again, thousands every single year. Docker is changing all the time. Kubernetes is releasing new versions once a quarter and aggressively deprecating old versions. Terraform is changing, right? Every tool we use is changing. And a lot of companies assume all that work they do to do the initial deployment, which is hard, is the hard part, and it just isn't. Depending on the type of software you're building, the maintenance cost is the vast, vast majority of the cost. All the stuff that comes after the initial deployment is actually like 90% of the cost you're going to be paying. And so if you don't have a maintenance plan, if you don't have a way of handling that, your code will rot and it will eventually stop working. So again, many of the companies we talk to end up in the situation where they put in all that work to write the CloudFormation code or the Terraform code or the Pulumi code, and they got it working. But then they got the thing deployed and then they went away and did other stuff for like 6 months, a year, 18 months. And then they come back and for some crazy reason, nothing is working anymore. And it's because their code rotted. How do you fix this? The solution is to set up automatic updates. Basic idea is there's new versions of stuff coming out all the time. And what you want is you don't want some human being responsible for pulling in those updates, but you want it to be completely automatic and ideally GitOps driven. In other words, a pull request is opened automatically whenever there's a new release or on some kind of a configurable schedule. Another absolutely critical ingredient is you have solid automated testing in place. People know about this for application code, but infrastructure code, it's a lot harder, but it's even more critical. Because if you don't have those tests in place, then even if you get those pull requests, you won't have the confidence to merge them, or you will merge them without any testing, and then things will break. And then you definitely won't have confidence to merge ones in the future. You also need automated deployment. So the auto update system has to be very intimately tied with the auto deployment system because you want to update one environment at a time. Dev first, then stage, then prod. This is actually a pretty new space, and the tooling out there doesn't handle it very well, just as a heads up. So you have to do a lot of work here. So key ideas, updates are pushed to your repos via pull request completely automatically, doesn't depend on a human. And if you don't have automated tests, your code will rot. It's not an if, it is a when. It is guaranteed your code will stop working. If you're not really tired of listening to me talk already, and you're willing to watch another talk, I have a full dedicated talk about automated testing specifically for infrastructure code, because that's the less understood piece. So there's a link in the slide deck. I'll put all of this into the Slack channel after the talk. Okay, we're almost at the end. So these are the 5 things that go wrong. Quick recap. What were the key ideas we talked about? So 1, manage everything as code. I hope if there's one thing you remember from this talk, it's this idea that you really do need to manage everything as code. 2, get that landing zone in place as early as you can. 3, only your CI/CD pipeline should have write access to prod. And the only thing your CI/CD pipeline should deploy is from your service catalog. That's how you build this API for the cloud. CI/CD pipeline needs to protect its admin permissions. Any team should be able to deploy from the service catalog, no gatekeepers. And any team should be able to contribute back to the service catalog with code reviews and tests. You should get updates automatically, not rely on a person to do it. And if you don't have automated tests, your code will rot. Okay, so we talked about 5 problems, ClickOps, everyone's an admin, etc. And we talked about 5 solutions: service catalog, landing zone, CI/CD pipeline, self-service, automatic updates. These are the Gruntwork production framework. So there we go. So now you hopefully understand where these 5 things come from. We believe these are really 5 central ingredients you need to have in place to use the cloud successfully. Typically, you put them in place roughly in the order listed here. Start with a service catalog, add your landing zone, add the pipeline, excuse me, etc. Final thing is just a very quick piece where I want to kind of paint a picture for you of what your world could look like if you actually follow that framework, if you put those 5 solutions in place. So first, what does the world look like for your ops team? For the ops team, the first thing they're going to do is put that service catalog in place. So remember, define everything as code, make sure you have infrastructure and application code in there, and you can build it from scratch, or you can build on top of existing materials that are out there. Step 2, get that landing zone in place, figure out your account structure, get those baselines in place, get really good control over authentication and authorization. Step 3, set up your CI/CD pipeline, make sure it's the only way to go to prod, and make sure it works for both app code, which most people know how to do, but really think through the infrastructure code. It's critical to get that right. Step 4, you set up some kind of a self-service solution. Starting with GitOps is a perfectly good way to go. Step 5, get those automatic updates in place. If you do that, the experience for the dev team is almost magical, actually. So step 1, the dev team goes into the service catalog and they use it to scaffold a new app, a new Rails app, a new Java Spring Boot app, whatever it is. Or they use those patterns to update an existing brownfield app so that it works in the cloud. And the patterns that you get from the catalog are things like how to do service discovery, packaging, monitoring, all of that is just built in. You have code examples and little reusable libraries to do it. Step 2, you go into your self-service solution and you use the service catalog and the pipeline to deploy the infrastructure for your app. Step 3, you now have a running app, you iterate. And step 3 can last for years, of course. And what happens is every time you make a change, you open a pull request, the CI/CD pipeline that was in your templates runs tests. When you merge the pull request, the CI/CD pipeline deploys that thing across your environments, promotes it, eventually to production. I'm starting to lose my voice, apologies. Step 4, if you run into issues, your application and infrastructure templates have all of the logging, monitoring, et cetera, built in. So you have a way to do that. And step 5, you get pull requests automatically and those run tests automatically, which keeps you up to date. So if you do all of that, you will end up with this lovely 1836 painting called The Cloud You Always Wanted. Thank you very much. I'll take a look and answer some questions now. Thanks, everybody.
Yevgeniy, thank you. That was awesome and very informative. I was going to say we could wait here. It does seem like some people are typing, so we'll kind of wait for some questions here as they roll in. And if there's none, we can end it early.
I will share the link to the talk in the meantime, or to the slides rather. Here we go.
Thank
And
you.
that has inside of it all the other links that I talked about. Oh, I guess I'll link to the production framework as well if that's useful. Okay, so looking at what's in the room, AWS Lambdas and managed services looking really good right about now. Managed services, absolutely. They do help quite a bit. AWS Lambda for certain use cases is a delight. For some use cases, less of a delight, but that's a longer rant that I probably don't have time for today. Let's see, Scott is writing, I work in Big Pharma, a highly regulated environment that's deeply mired in manual testing and validation. All this seems like a pipe dream. How much can I apply to that kind of environment? Good question. We do work with a very large number of companies that are in a bunch of regulated industries, very regulated financial environments, healthcare, et cetera. And I will not sugarcoat it and say this is like some easy thing and you click a button and you're there, but it is possible. It's absolutely possible. And usually what works to get there is you have to solve very concrete, specific pain points. So one of the things that I probably should have mentioned in the talk is you don't adopt the cloud and DevOps and all of these changes all at one time, right? There's like 1,000 things that are changing. If you try to do it all at once, it just doesn't work very well. So typically the formula that works is incrementalism. You find one very concrete pain point that your organization has, and you solve that specific pain point. So as an example, something that I mentioned a little bit in the talk that comes up a lot in these regulated industries is there's all sorts of auditors and people that want to know, did you do this? Did you do that? And the answers for a long time have been manual processes, right? Oh, we have a wiki page that says we do this process. And we have a PDF that everybody read that says we do this process. And one of the big shifts that's happening is to enforcing a lot of those kinds of things through code. And you can actually show the auditor the code, the output of the test results, that you're running them every hour or whatever makes sense. And that's the kind of thing that can save your team crazy amounts of time. It can actually help you be more compliant. It can help you pass audits a lot faster. So that could be a pain point. If you've got an audit coming up, like that could be one little piece that you put in place and already make things a little better. If you have a pain point like deployments are always causing outages, using code can help tremendously because you basically take the human error issue out of the equation. So maybe you encode some small part of your infrastructure initially as code, and at least that part is working better. And so those deployment errors go away. So solve one problem at a time, and you really can improve things. But it's not easy. It is not a a weekend journey. It takes time.
We probably got to wrap up now. The meeting's self-destruct
Okay.
at 10 o'clock. So thank you
Perfect.
very much.
I'll try to answer some questions asynchronously in Slack.
Okay,
Thank you,
awesome.
everybody.